Hello and welcome back to my channel. In the last lecture, we have discussed about what electrochemistry is, how many types of cells we have, what is attackable electrode, what is non-attackable electrode, what are the types of cells we have, how they look like. Then we discussed about where reduction happens and where oxidation happens. Now it's time for us to continue with the lecture and go to the next topic of this chapter. So let's start with it. So let's start with the next part. So we'll start with the next part where we'll be discussing majorly about galvanic cell. Now this chapter gets divided into two parts. Up until now I was discussing overall here, but now I'll start with one part which is galvanic cell. So this discussion, in fact the upcoming few lectures, will be all about galvanic cell. Up until now we have discussed both the chapters in common. We have been doing common concepts, but now our chapter will be specific to galvanic cell. And once this gets over, we'll start with electrolytic cell also. So let us start. So let's begin with the topic galvanic cell. So what is galvanic cell? The definition is already covered. It's a cell in which, yes, electrical energy is produced by a chemical reaction. It's a cell in which a chemical reaction produces electricity, which we already discussed. So I'm not going to write the definition once again. It's there in the notes that I have attached with the video. So chemical reaction gives you electricity. So that's what is the purpose of galvanic cell. So galvanic cell has two parts, as I told you. There are two containers, as I've told you. Yeah? So let's begin with that. So it's a cell in which chemical reaction gives you electricity. Now, let's talk about the next part, which is, let's talk about the next part, which is an example of it. Yeah. So let's look at an example of this. Typically, a galvanic cell has how many containers? Yes, correct. Good. Two containers, right? One of the, or we can also call it as compartment. So one of the compartment can be called as anode. I'm just randomly writing, but typically we write left hand side anode, right hand side cathode. You'll learn it why in some time. And then what do we put into it? Yes, a metallic conductor. So we dip in any conductor, we dip a metallic conductor. Suppose I'm taking zinc sulfate where zinc rod is dipped. And now I'm taking a blue color solution, our favorite copper sulfate, copper in it. Now we're joining them and there is a machine, just to see the voltage flow, right? So anode, cathode. And this particular cell is called as Daniell cell. Okay, it's called as Daniell cell. So what's a Daniell cell? It's an example of galvanic cell. If your anode is fixed, that it is a pair of zinc and zinc sulfate, and if your cathode is fixed, it to be copper with copper sulfate, then it is said to be galvanic cell, right? So anode has zinc zinc sulfate, cathode has copper copper sulfate. That's galvanic cell, specifically Daniell cell. Now next part, this is how the construction go like. We need salt bridge also, but this is something that comes later in this chapter. This is salt bridge. Why and if all these things I'll be answering it soon, don't worry. Salt bridge is also used. It's really important. Why? I'll tell you. So what is galvanic cell? It's a cell in which chemical reaction converts to electricity. Then we have, this is how the construction looks like. Now let's get serious. Let's talk about the real concepts. The heading is electrode potential. This is where we have to pay. So I want all of you to have a very undivided attention here. So this is a very, very important concept. Electrode potential. So what is electrode potential? So let's have an idea at this. Look at this. Whenever an atom comes in contact with its ion, whenever an atom comes in contact with its ion, comes in contact with its ion, there are two tendencies it can develop. Like for example, there's an atom copper, and it comes in contact with its own ion copper 2+. So there are two things that it can have. Can you guess it? If you have a copper 2 plus ion come in contact with copper, what are two things that can happen? So the two things that can happen is copper can become copper 2 plus, copper 2 plus can become copper. So if copper 2 plus becomes copper and copper becomes 2, there are two different things going on. So if copper becomes copper 2 plus, then we'll call it as, yes, very well, we'll call it as oxidation, because the charge has to be equal. Left hand side is 0, the right hand side will also be 0. So 2 plus minus 2 will give you 0. This is called as oxidation. Why? You can visit, yeah, what is oxidation? As I told you in the last class, increase in oxidation number. See, oxidation. The other possibility is copper 2 plus might gain 2 electron and become copper. This is called as reduction. So whenever an atom comes in contact with its ion, it can have two possibilities. It can undergo, or it develops. The better thing would be to say like this: whenever an atom comes in contact with its ion, it develops two types of tendencies. Two types of tendencies. One is to undergo reduction or to undergo oxidation, and the other is to undergo reduction. So whenever an atom comes in contact with its ion, it develops two types of tendencies. One, it can undergo oxidation, and the other, it can undergo reduction. So the tendency to undergo reduction is called as reduction potential. What is it called as? Reduction potential. This tendency is nothing but the other word for potential. Don't get confused. Simple. Tendency is nothing but the other word for potential. But my tendency to work is my potential. So the tendency to undergo reduction is called as reduction potential, and the tendency to undergo oxidation is called as oxidation potential. So can both happen? Of course no. Only one of the thing happens. So this was the concept. Whenever an atom comes in contact with its ion, two things are possible. Either the atom can become ion, meaning it will become solid to aqueous, or the aqueous can become solid. Either of this can happen, not both. One of this can happen. So I hope you have done it. So you can take a screenshot of this. I'll wait. Okay, let's go to the next part now. Out of both the tendencies, only one can take place, right? Only one can take place. Now, how do we decide what will happen? Which is decided by the other pair of, yes, atoms and ions. Basically, let's try to understand. Suppose on the left hand side we have a copper atom come in contact with its copper ion, right? And then we have a zinc atom come in contact with its zinc ion. Good. So what are the possibilities we can have? Yeah, we can have possibilities like copper solid might end up becoming copper 2 plus aqueous and giving 2 electrons. And the other possibility, copper 2 plus aqueous can gain 2 electrons and become copper solid. That's a possibility, right? I mean, let's see whether it happens or not. But it is a possibility. Zinc solid can become zinc 2 plus, see, aqueous, or I'm sorry, yeah, or zinc 2 plus aqueous can gain 2 electron become zinc. What will happen? What will happen? That's the biggest question that we have in mind. So who will answer us? I mean, see, one of these can happen. Only one of this takes place. Only one of this happens. Here also, only one is possible. Which one? Which one it is? So how do we answer that? So we answer that using a chart that is available in chemistry or in the language book. That chart is called as reduction potential or oxidation potential. So it is decided by the reactions are decided by by two things. Yeah, the reactions are decided by either something called as reduction potential or either by reduction potential or by oxidation potential, right? But only, I mean, I know we have too many choices. We can use reduction potential also to judge or oxidation potential also to judge. I would say for our NCRT perspective, for CBC, JEE, NEET perspective, we will always use reduction potential as our basis. Okay, I'll explain what I'm talking about, don't worry. We'll always use reduction potential as our basis of selection. Now have a look. See, suppose the value of copper 2 plus becoming copper and the value of zinc 2 plus becoming zinc. Let me first tell you what this means. That is much more important than solving the question. See, have a look. This symbol is nothing but implication of standard condition. Just for now, just understand that it is standard. This is the ion, this is the atom, right? So plus 2 to 0. What is happening here? Reduction. Very good. Reduction. What is this E? Potential. So basically it is nothing but the value of standard reduction potential of copper 2 plus ion. How about this one then? This is nothing but standard oxidation potential. See, it is nothing but standard oxidation potential. So standard reduction potential and the value, if you look at the book, the value will come out to be plus 0.34. Now don't worry, you don't have to remember this. You don't have to remember this. This is 0. minus 8.0.8 volts, 76 volts. Now you tell me which one is a greater value. Is the reduction potential of copper more than zinc? Yes. So please understand this point. First take a screenshot. Okay, let's go to the next part. Since the reduction, or I would say standard reduction potential of copper 2 plus is more than standard reduction potential of zinc 2 plus, what will happen? Copper 2 plus has a greater tendency to undergo what? Very good, reduction. To undergo reduction than zinc 2 plus. So therefore we can say copper 2 plus undergoes reduction. So what will happen to copper? Zinc. If the zinc has to has to exist in the same cell, zinc has to undergo oxidation. There's no other way. Even if he wants, he cannot undergo reduction. Reduction will be undergone by copper, and zinc will undergo oxidation. Meaning, out of all these 4 reactions, which will happen? This won't happen. This will happen. See, this won't happen. And here, this won't happen. Because this is what, right? Copper is undergoing oxidation, reduction, sorry, and zinc is undergoing oxidation. So out of these, only one, and out of these two, only one will happen. So basically, copper reduces, zinc oxidizes. This is the entire chemistry behind finding which will undergo what. And this is the story of electrode potential, which was a very, very essential concept. So just to summarize, I would say a very, very important statement, which is higher the potential, higher the value of reduction potential, higher the value of reduction potential, greater the tendency of reduction, right? This is the concept. Meaning it should be more in value, meaning more positive or less negative. That's it. Like for example, what is this potential? What is this standard? What is A plus becoming a standard reduction potential? So minus 2 volts. Suppose this is the value. Suppose it is B plus B. What is this? Standard because of not B plus to B. So reduction E is potential. Minus 1 volt suppose. And this is C plus C. And that is suppose 1 volt plus 1 volt. So which one has the highest tendency? So order of reduction tendency will be, can you guess it? As I told you, higher the value of reduction, greater the tendency of reduction, right? So reduction tendency will be C plus will be highest because it is plus. And these two are negative. What now? The one which is less negative is a better choice. This will be the order of reduction tendency. It's a very, very important concept which we will be needing a lot in the problem solving part. Now let's go to the next part. So please take a screenshot of this one as well. Thank you. Let's move on now. Next part is there will be question asked on oxidizing and reducing nature. See, if a substance undergoes oxidation, if a substance undergoes oxidation, it is said to be a reducing agent, right? We know the concept. This is called as reductant. This is called as reductant. And if a substance undergoes reduction, if a substance undergoes reduction, it is said to be, yes, oxidizing agent. Excellent. It is said to be oxidizing agent or oxidant, right? So if a substance undergoes reduction, it is said to be oxidizing agent, and the substance that undergoes oxidation is said to be reducing agent. So I'll give you a concept, then we'll do 1 or 2 questions on this. So to sum up, see, if please note it properly, first ion and then atom, meaning there should be a reduction. If reduction potential is high, the reduction happens more. So it's a good oxidizing agent. Keep in mind, this is the concept. And if reduction potential is less, so reduction potential is less, reduction will be not that common. It's a poor oxidizing agent. So this is the concept. So based on this, I'll give you a quick question and then we'll wrap up this video. This is a very important concept. Write it down or take a note, take a screenshot. Next. See, Question. Arrange the following in increasing order of oxidizing power. Oxidizing power is same as oxidizing agent power. The questions are E naught Cl2 becoming Cl minus is, suppose some value minus x. I don't know what it is, but I have to tell you. Yeah? So let it be minus 2 volts. It doesn't have to be correct. I'm just telling you. Yeah. And E naught of MnO4 minus becoming Mn2 plus is minus 1.5 volts. Suppose. Yeah. This is maybe plus 2 volts. And E naught of H2 becoming H plus is suppose 0 volts. So you've been asked to arrange them in increasing order of oxidizing power. How to solve it? See, how to solve it? We can solve it like this. See, we can solve it somewhat like this. Have a look. What potential is this? Cl2 is 0. Cl has become minus 1. So 0 to minus 1. What is this? Reduction. So this is reduction potential. Let it be the way it is. Yeah. E naught of MnO4 minus becoming Mn2 plus. What is this? It was plus 7 here. It became plus 2. So reduction, which is correct. It's 1.5 volts. This guy, although it doesn't matter, let me change this question. Otherwise, this will not be fun. So let it be some other element, zinc, suppose, and that's 0. Plus 0.76 volts. Yeah. Now, what is this? They have asked you to compare these three. This is reduction potential. This is reduction potential. But what is this? 0 to 2. It is not reduction potential. This is standard oxidation potential. So can we compare them? No. It's like there are 3 students. Okay. You are studying in you are writing biology exam. He's writing biology exam. The other guy is writing computer science exam. And now we're comparing them in order of their how intelligent they are in biology. It makes no sense, right? Yeah. So we need to make sure that the third guy is also writing biology exam. Okay? So what I'll do is I will convert them into reduction potential. How to do that? Very easy. Very easy. Just keep in mind standard oxidation potential and standard reduction potential have same value but opposite sign. That's it. They have opposite sign. That's it. No change. So it would be SOP is more than, a same value. So it would be, this would be E Zn2 plus becoming Zn has a value of minus 0.76 volts. Now just have a clear investigation and get the answer. So here it is 2, here it is 1.5, here it is 0.76. So which has the highest reduction potential? Of course, chlorine. So chlorine has the highest oxidizing agent tendency. Then this one, see, it is less negative. So zinc 2 plus, and then MnO4 minus. So this is the oxidizing power order. So that's the answer of this question. So there are similar questions which I've given in the worksheet. You can take and solve them for your own practice. But these concepts that I've given you are really important concepts. This one, this one, this one, this concept, all of these are really important. So just to summarize, if there's a question where you've been asked to find reduction potential, oxidation potential, all these things, or oxidizing power, just think about that. This particular statement that I'm telling you. If oxidation or reduction potential is high, it will undergo reduction, a good oxidizing agent. That's it. Make sure that whatever question is given to you, all the data is in reduction potential. Otherwise, the answer will be wrong. So this is the answer. And this is another concept that I told you, that suppose you have a oxidation potential given. If you want to find reduction potential, just reverse it. Put minus sign. So with this, we are done with this concept also. Next lecture, we'll see other parts of it. So I hope you have understood the things we discussed. If you're enjoying this series, as I told you, you can share it with your friends, spread it. Let this, let this lecture be helpful to many of the students. And if you're liking it, do like and subscribe. Thank you so much.